right. All right, we'll give it just one more minute. I'll try and remember what it was that I planned on doing today. Thank you very much, Bob. Oh, wait a minute. No, I'm not muted. Why did I say Mike is muted? All right. Good evening, ladies and gentlemen. Welcome to Sidetrack Sunday. So glad to be back. Thank you all for joining. We are live. Yes, we are. So, I guess I'll tell you real quick. Yeah, I haven't been here for a couple of months, and no big deal. It's just that, of course, the holidays were busy. And then the Rick said he would like to do a show. So I said, you know what? I could use the break. Go ahead. So I just took a break from January. And then February, I had planned on going to, I thought I was going to have to go to Florida. And Brian from Iron Horse Hobbies said that he was going to go. He was going to do a show. So I said, go ahead. That's fine, because I'm not sure exactly when I'm going. But it turns out I never went to Florida. I just took my wife to the airport, and she went to Florida. And Thursday, I'm going to Florida. So that's what's going on with that. So let's go ahead and get to the you can hear me, right? Everyone, chat is too fast to keep up. That's all right. Welcome. Let me go ahead up to the top here and see who is in the house. Wow, a lot of people joining early. Of course, Bob from PK&W Model Works, Thomas Grassi, Elmar. Thomas, I have something we talked about once before. I'm going to show you. Elmar, Schuylkill River Valley, John number 2. Stormy Sky Rail Productions, Ray Bobel, Grandpa Rails, Chuck Schreiber, thank you for joining. The Rickster, Fultz Bailey Model Railroad. 1, 2, 3. Okay, it's keep getting a notification my mic is muted. That must be the other one. Joe Rader, thank you for joining. Great Northern JJ. Rails. Happy Valley Hobbies, Edward. Deep Run Railroad Mike. Del Hudson. Well, I was taking it easy today. I knew I had to talk. So, John Benicki. Wait a minute. My mouse is a little sketchy today here. Midsummer Railways, N-Scale. John Benicki, Joe Rader, Elmore. Curly Express, thank you for joining. Just looking through the list here. Wigwag Workshop, thank you for joining. Okay, you can hear me, right? Because I keep getting a notification that says mic is muted, but it might be the other microphone that's muted. And I get the little green dots that say that it's making noise. Okay, sounds good. Thank you so much, Bob. Okay, so like I said in the description there, we're going, oh, I know why, because I'm on the other channel. There we go. If I just switch to the other page here, then that will 5x5. Yeah, if I go to the other tab on Firefox, then we are good. So yeah, like I said, what we're going to talk about is power supplies for DC, AC, and voltmeters, displaying your voltage and so forth. Sparky, my man, just showed up. All right. So I'm going to start with the DC power supply here. Here's the drawing, and let's see. I'm not sure. I'll tell you what. I'm going to go through this, show you what I'm going to do, and then I'll put the image up because I also have it as a PDF, and I can just put it up there and screen share. So we have a power supply here. What we're going to use is a laptop power supply. And the reason for using a laptop power supply is because this one puts out like 19.5 volts. Yeah, 19.5 on that. So you're not getting cheated. You know, you got plenty of voltage, and even if something gets loaded down. And then over here, we have a motor speed control. This guy right here. And what that does is actually controls the voltage, and it does it with pulse widths, just like your DCC, pulse width modulation. So that would be right in here. And then we're experimenting with different voltmeters here that you would put in parallel. And this is one of them here. I have a couple different ones here. And I'll show you some of them online. And then we have, now I showed this with a reversing relay. And I also have it wired as, well, for this example, I have it wired as a switch. And I'll explain that. Here is what it would look like if you, wait a minute. There we go. Does that help? There. Okay. If you wanted to have, say, an automated line like a trolley line or something, you can use a relay. If you had an automated line like a trolley line or something, you can use a relay. I say that because I have a good friend of mine that's working on a project like that. So if you wanted to reverse the voltage on your DC line and have it go the other direction instead of using the switch like this, then you could use the relay thing. And then over here, I have a motor just for testing purposes. I think I zoomed this out as far as I can. Let me go just a little bit further. Yeah, there we go. That's better. Hold on. Sorry about that. Okay. So what I'm going to do, add the stage. There we go. Can I zoom that in any? Darn it. Oh, yeah, we could do that. Okay, I don't know if that's any better or not, or easier to see. But that's basically the drawing that I have in front of me here on the table. And that is the drawing in a PDF. So if you want to do a screen capture on that, just for the fun of it, it's available. Okay. Is that better? Okay, good. Okay. So we're going to stop sharing that, and we're going to talk about this power supply here. So like I said, we're starting with a laptop power supply, and we're going to control the speed or the voltage going to the motor with this. So I'll tell you what, we'll just go ahead and power this up. Well, yeah. Trying to figure out what orders to do this in. Okay. Oh, I'm sorry, that screen is probably flickering. The LED is probably flickering. Okay, so as we control the voltage, of course, on here, that goes up. We're going to see sparks tonight. We might see sparks. You never know. So then if you wanted to turn it off, switch direction, we can do that. So that works. So let me, wanted to share a screen. Let me, okay. So this is showing you a DC motor speed controller. And again, like I said, they're with pulse width modulation. And you can get all kinds of different things. Like this one says 12 volts to 40 volts. That wouldn't be what we really want. Here's some cheap ones here. 2 pieces, $8.95. So it's about $4 a piece. 1.8 volts. Yeah, okay. So there's some different options there. Here's one that's 40 amps right there. This is pretty close to what I have right there. That one says 4.5 volts. So I think you want something a little bit lower than that. Let's see, those are heavy duty ones there. 10 to 50 volt, 40 amp. We don't need that. It's pretty complicated. Here's another nice cheap one here. 3 volts, 6 volts. Okay, 5 amps. And I guess some of these are a speed controller with the display on it. So that's handy. I haven't seen that before. Let's see real quick. Well, let me, no, it doesn't show it there. Okay. Here we go. Now this is nice because it's got an external, it's a separate device, the first one here. And then it has an external voltage controller, you know, and that one probably carries a little bit more amperage on there. Just notice YouTube gives a participant list. Don't need the duck. Mason Dixon, welcome. Sorry. Okay, so anyhow, so if you're looking for a pulse width modulated speed controller, that's the kind of thing, you know, there's some examples there of what you want, you know, anywhere from like $4, $8 or something like that. So that's that. Your voltage, your LED displays. Now this is kind of a cheap one here. I guess that would work. You can get it in any color. I'm not sure about this here. So this one here, if you look at it, it shows only from 4.5 volts. So you wouldn't be able to do that. Yeah, that one's kind of the same. Doesn't tell you the specs on that. So this one here, 5 to 30 volts. Now that's a nice meter, but it doesn't display any voltage until you get to 5 volts. So here we go. Here's a nice one. Well, it doesn't have any kind of trim on it, but 0 to 30. So that'd show you lower voltage on it. 12 to 24. Okay, so I just wanted to show you those things. You know, if you wanted to build one, those are the specs that you would look for. You know, make sure that it will measure lower voltage. Okay. And then there's different options, and I'll show you a second one that I have that also displays current. We'll see if you do that. There we go. This is nice. 0 to 30 volts. So that's pretty cheap. And it looks like so it's got the trim on it and everything, nice cover on it. So yeah, Evil Bay. Amazon, yeah, and I may have even bought some of this stuff. Where's my mouse there? Yeah, I may have even bought some of these on Amazon. I don't remember specifically. You know, it's just I go searching for things and we'll see what comes up. So some of them I order from I order from the United States when I can. If there's something that I'm not in a hurry for, and I'm like, well, I'll order it and I don't need it for another month, then if you order from China, then that's fine. 24 volts, 10 amps. Okay, that's pretty good. Okay, good. Okay. Okay, so like I said, I just wanted to show you what's available, and if you wanted to, do a project like this, what you would be looking for. So while we're here, we can see exactly how accurate this is. Again, probably like a $5 to $10, more like about $8 display there. And I'll show you this. I do have this upstairs in a working condition, and you can see my meter. Yes, you can see. Just put it in the light there. Okay. So what happens when we put some voltage to it? That's not too bad. So this is showing 5.42, and this is showing 5.47. We're at 6.24, 6.31. Okay. So that's not bad. I mean, it doesn't have to be perfectly accurate. The reason I like to have a voltage display on there is so you can kind of see the health of your trains. If and I'll show you what I mean when I run a train. If you're normally expecting, you want to see that again? Okay, you want to hear the motor run. $13. All right, there's a full 19.7 volts. That's what you get. So anyhow, I like to have the display so that you can kind of see, and if you adjust your speed up to like halfway, and your meter's showing you it's at 8 volts, well then you know that there's something wrong with your motor. So ludicrous speed, yeah. It almost did. I tried it's funny because when I was testing this, I was using a small hobby motor, and that thing went crazy. So we always got to sneak a little bit of 3D printing in here. So I 3D printed these. The link is in the description down below. So I made these also for like a rocker switch or a push button switch, like that. So yeah, this is the same thing here. I made 2 of them. So if you need a switch somewhere on your layout at a random place, it's a handy little box to have. And I made it with holes in the side, so you could just screw that into the side or on the top or whatever. Didn't go plaid though. So yeah, boxes for your switches. So let's see if I don't know if this is going to display or not. We're going to see if we can look at the actual signal with an oscilloscope. Yeah, check me out here, huh? I think this was about 50 bucks. And you probably can't even see that at all. Probably not. Yes, that's a Spaceballs reference, Deep Run. John Candy, right? All right. Sorry about that. I'm going to mess with you again here in the interest of trying to see this oscilloscope. And I didn't. Nope, not a chance, huh? Let me see if I turn this off. Almost. There you go. Can you kind of see it? Okay, I think you can see it there. So yeah, what you're actually looking at, it's not just the DC voltage, it is pulses. So if we increase it, let's see if we can see that. I was able to do it before. All right, so you can see they're getting wider. Let me see if I can set this to auto. This will take a minute. If you press the auto button, it should focus that that signal. There we go. Come on, stay right there. Oh, perfect. If that stays like that. So you can see the difference between like this line and that line. That's one signal. And what happens is the width of that changes. I'm sorry that it's not very bright. You see, as we adjust the voltage, so that's what a pulse width is. Okay, that's the purpose of showing you this, in case you've never seen that. Square wave pattern, roughly square wave. It's kind of a messy square wave. So then your DCC signal would have, depending on spacing and so forth. I'm not sure exactly how DCC works. Navigation systems, it would determine like how many pairs and so forth that would carry the digital information. Okay, so that's just to show you that what a DCC signal or a pulse width modulated DC signal looks like. Okay, anybody learn anything? Yeah, it's not bad. It'll run the trains, that's for sure. It's not perfect, but it's clean enough. I'm probably picking up a little bit of distortion from the lights or something else in here. Who knows? The heater's running. I don't know. So yeah, let me put this away. I actually found a use for this. Come on, shut off. For this cool little oscilloscope. Well, there we go. That's why I showed you. Let me back you up here. Close your eyes. Really need a better camera. I didn't realize the Rickster uses an overhead camera, but he uses it in OBS, and he actually digitally does a zoom on that. So in these voltmeters like this one, it's got 3 wires on the back. There's a red, a white, and a black. And the white wire is the sensitivity, or I'm sorry, wait a minute. Yeah, the white wire actually is the voltage signal. And then the red and the black, so you have to, jumper the black wire. And what I'm doing is I'm powering the meter with a 9-volt, see? So that gives you the back display on that. Now, I did test this, and what I could do, instead of using the battery, if I put it on that positive, like that. So once I get up to 2 volts or something, it's almost 2 volts, then it'll start to, yeah, right. So it starts to give me a display at about 1 volt. And then as I turn the voltage up, it gets brighter. So instead of having an external battery source on that, you can cheat and use that, is what I'm saying. I don't know if it matters or not. whatever. All right, we're here. We're still doing this. Have to be careful. Ray, I mean, this is how I run my trains with just like this setup here, and I'll run them for hours. Huh. I don't know. I'm talking about, 1970s Tycos and Bachmans and Lifelikes and stuff like that. So, yeah. I'm not sure what that is. Okay. Yeah, I don't have DCC. I've never worked with it. Yeah, so the pulses are going to be constant, and then I guess in those pulses is going to be the data or the information for a DCC. I've read it and I've seen pictures of it, but that's as much as I know. I'm not going to pretend like I know anything about DCC. Huh. Huh. Mine take off like crazy. Okay. So yeah, this is one of the meters, and I'll show you another one here just for the fun of it since we're here. Now this one has, here's a red and a black wire, and here's a red and a black and a blue wire. And let's see if I can remember how to wire this up with my little cheat sheet, because what that does is if I put the blue one, these cool little clips. Oh, no, I don't want that one on there. Let me just show you something a little different here about this other meter that I have. And in the large. Oh, yeah. Hopefully those wires stay in there. Okay. And then we are going to use these two here again. Oh, okay. I could do that right here. Stay with me, folks. Again, the 9-volt battery. What am I doing? That ain't gonna work. Do, 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 do. Okay, so this one has two displays on it. That has a voltage display and a current. And something, black one gets hooked up to here. Like, there's nothing connected to that. All right, let's see what this does for me. If I did it right. There we go. So this is showing the voltage and the current on there. Yeah, and they're all different. I think I have another one that's different. And again, some of these things are from China, and I get these drawings that like they got scribble on them, and you have no idea. You just have to guess at how you're hooking them up. So thanks so much, Ray. So keep it in the camera, right? Yeah. Yeah, so some of these guys, again, they come with instructions, and you're looking at them, and it looks like it's in Chinese, you know. So that's a DC voltmeter. At the end here, if we get through all this, we'll go upstairs, and I'll show you what I have upstairs. We were up to 33 at one point. Right now, we got 30. Thank you all so much, and I'm going to do something I have never done before, ever. I never, ever in my videos say like and subscribe, put a comment down. I just say thanks for watching. I am up to 981 subscribers. I need 19 to see 1,000. If you subscribe for a week, just so I could see 1K. I want to see it. But thank you all so much for being here. Okay, we're going to take this apart for now. We don't need that. So we're going to move on to AC. Do I need any of this? I don't think I do. Right, because we're not controlling the voltage. So we use this incredibly dangerous power supply from 1950, and we'll connect it to a voltmeter. Sorry, we can't use the motor. The motor will probably catch on fire unless you really, really want to see sparks. Then we can hook up an AC power supply. We can hook up an AC power supply to a DC. This is actually a drill motor. We can hook up hook it up and see if it burns up. I don't know. Get that in there. That worked. That worked. Okay. So we are going to move on to bridge rectifiers. Let me find that drawing up here. And go back to share screen. And we'll zoom that in just a little bit. Okay, at one time I did a video on LEDs and how you need to put a bridge rectifier in there so you don't burn up your LEDs when your train goes in reverse. And also, of course, you can use this for your Lionel AC transformer to display the voltage, because to get you really can't get a AC voltmeter. You have to get a voltmeter, a DC voltmeter, and use the bridge rectifier with it to read the voltage. So okay, so that's a bridge rectifier, and you have AC in, and it also works for like alternating DC. In other words, if the top input and the bottom input flip, then it still stays the same, because the diodes only conduct electricity in one direction. I'm not going to get real complicated, but it's kind of like a one-way valve or something, so that the output is always positive on the top here, and the output on the bottom is always negative. So that's basically what a bridge rectifier is and how it works. Okay, that's the quick and dirty. If you want more on that, I went in detail on the video that I did on LEDs in your model trains. So this is what a bridge rectifier looks like. They're usually a square with the little notch on the side there, and the little notch on the side there is always the positive. So you have two inputs here that are AC. No playing electro, boom. No, I can't believe nothing blew up yet. So I'm just going to show you this. I don't have a load to put on it. I didn't have a Lionel train here. So, and I'm not going to do, because I don't have a load, so I can't show you the one with the amp meter on it. So I'm just going to show you this one. Where's my glasses? I need my glasses to find my glasses. Okay, negative goes there, positive there. We got an extra negative on that. So that's my sensitivity. And then this would be for my battery. Let's see, leave that one connected to there. Okay. Again, we're kind of seeing the sketchy looking LED. So here's my 1950s incredibly dangerous power supply. And you can kind of see that in between the blinking. And so that's showing me 10 volts there. 9. On that. So actually, this power supply puts out, it says 7 to 21. No, there's no way. 7 to 19 volts. There's no way this is going to put out 19 volts, but let's, you know what? 12.7 is the most I'm going to get out of this one here. Okay. So that's so you have some, you know what? Yeah, we're going to do the same thing on that. So we have to check this with an AC voltmeter. If you're into O gauge, Dell Hudson. So what is this actually showing here? 11.2 and 9.8. Wow. So that's like a volt. Tell you what, let me round this up to 10. Okay, that's 10. So we don't have to do too much math here. 10 and 11.4 on the fluke there, or the actual meter. So you do lose some voltage going through the voltage regulator here, or the bridge rectifier. You do lose a little bit of voltage. And again, you know, we don't have to be completely perfectly accurate. It would be nice if we were a little bit closer than 1.5 volts here. What did we say? 1.4 volts? Yeah, 1.4 volts difference. It'd be nice if we were a little bit closer, but again, that gives you a good idea of the health of your train. Transformers are AC, power packs are DC. You can say that. Yeah, I don't get caught up on terminology too much. I mean, I try to keep things correct, but yeah. If I get 1K, will I do a happy dance for you? I don't know what kind of happy dance you want. You tell me. Okay, so that's that. Was there something? Oh, I know. So, so where's my mouse? So what I would really like to get here, I'll tell you what, I'll buy everybody lunch. If I get to 1K, next train show, I'll buy lunch, okay? So, if I had the money here, this would be what I want. $1,000 for this, for your Lionel with those little meters on it. So that would be sweet. So that's the ZWL transformer from Lionel. Yeah, right. $1,000. I mean, I love my trains and stuff. I'd have to. Yeah, my mouse is in my hand, but I don't know where it is on the screen. How we doing here? Okay, 8:40 almost. I would say we were about right on schedule. Maybe me and Del can get a twofer on these guys or something. I don't know. Okay, so then your other option is this MTH guy. I would not recommend it. I mean, this is sweet. It's got the voltmeters right on it, and it even has amp meters on it. And then it's got all your other things on there. If you're into what do you call that? Command control. But I haven't heard of anybody that said this was a good transformer. I've seen them at train shows in rough shape. If you ask Nick from Nick's Crossing, he says it's a piece of junk. And I've heard that, you know, these displays quit working. It's a shame, but that's a cool looking transformer, and it's got all the options on it. But unfortunately, it doesn't work. So don't spend your money on it. Sorry, I don't like to trash things, but if it doesn't work, it doesn't work. That's 650. So, okay, we need to go the other way. Yeah, that was showing the retail price on that, on both of those. That's the retail price. Yeah, right. We'll take donations at the next meet and greet. Yeah, yeah. What else did I miss here? Three Locos. Um, Everybody knows how cheap I am. Like Lionel's or the O gauge, I guess the most I've ever spent was $110 on one, and my Tyco's on the HO 10 or $12, but that's because it'd be cool to print one just to have it sitting there. Yeah, I heard that's a pretty good deal, Sparky. I mean, I think that's what most people have, and they seem to like it. Okay, let us know. I do what I can. Well, I don't know about that. I mean, they've been around for years, but yeah, they still hold their value. I mean, I've seen people sell them used for 800, 900. So, Ray Central, welcome. Thank you very much for joining us. All right. Was there anything else I forgot? I did actually write out a list here of what I wanted to go over. Oh, shoot. Yeah, the big project here. Okay, let me turn that down so we don't blow anything up and disconnect this, Jimmy. Oh, man. I've got something to show you. Take this off of here. Done with that. We're done with that. We're done with that. All right. Okay, we'll put that over here. I'm going to need a screwdriver. We will probably be going a little bit over here. I knew that we would. Got a lot of good stuff here today. Where is that USB cable? I can't believe this. Don't panic. We had it. I had it. Put it somewhere very important. I need a USB cable for that. For the Arduino. Don't panic. I believe in this. Okay. You know what? I don't believe. Nope, that ain't it. I don't believe this. Like right before we started this, I couldn't find that USB cable that I needed, and I pulled it out and I set it somewhere where I wouldn't lose it, and now it's gone. Let me, what am I doing here? I have to go to that. Hold on a second. How to minimize. That. Okay. All right, bear with me, folks. So I need to connect that. Did that not work? You telling me that's not going to work for me? Trying to hook up my no board selected. Trying to hook up my Arduino here. Okay, it says it's there. Uploading. Good. Uh-oh. No, it's not uploading. Where is that daggone cable? Old bootloader, that's what we need. Come on, baby. Uploading, done uploading. Okay, is it uploaded? Perfect. All right. So what I have here, I'm going to zoom in so you can see the display. This is called a ZMPT101B. Now, I started this project a long time ago, and I'm still having problems with it. And again, this is to display voltage from my AC transformer. And I'm not going to bore you. I know not everybody is into Arduino. I'm going to have to get that display in there. You could just barely see that, I'm sure. Dog it. There we go. Can you read that at all? The display right here? Uh-oh. I missed a whole bunch of them. Randall Ellison's in the house. Is that a Nano? Yes, it's a an Arduino Nano. So anyhow, thank you for your patience. So we have a display here that says track 1, and that's the voltage of it. And so we go up to 10 volts here. Let me see. It's a little bit hard to read. Fully read it? Okay, good. So as I adjust the voltage on the power supply, it will show you. So cool, huh? You track 2. There's nothing on track 2. In other words, I would have to have another one of these guys on another input, and it could read it. I mean, I did the software for it. It'll do it. I didn't wire it up because I did this, and I'm looking at it, and the size of that screen isn't going to do what I want it to do. In other words, I want to be able to stand, 5-6 feet away from it and see the voltage. And I can only see it. I mean, I can barely see it from here. So that's not going to do what I wanted to do. I did try and do, so I got these LEDs here, and the code's not working. In other words, I can get this to show a display on there, but when I try and use it with this sketch that I wrote up, the software, I'm getting a lot of blink. It's trying to refresh too fast is what's happening. So what happens is the LED just blinks a lot, and that is, there we go. Okay. But anyhow, I was able to successfully use this here, the AC interface with Arduino, and I do get a voltage out. And I guess since we're here, so that's showing me all kind of different voltages, 10.9, 11.2. I mean, this transformer too is not the most reliable. $10.9. I'm sorry, that's out of. Okay, so that's giving me 10.9, 11. So it's kind of floating around. That's not in camera. I know that. I'm sorry. I was just trying to see what it looked like on the voltmeter. So yeah, that's the project I was working on, and I was going to have track one. I was going to have 4 tracks on there, and realized I'm out of pixels. So whatever. Okay, I'm going to show you one other thing here. Thomas Grossi, you're going to love this. So Thomas Grossi and who was Artie were asking me about this. They said, can you do that with an Arduino? I said, yes, you can, and I'll show you. I guess is it still uploading? Or what? What's going on here? Oh, maybe it did. Okay. So let's see if I turn this off. Is that easier? Maybe. Okay. So you can kind of see that. There we go. So you got a billboard for your track. So that's showing Baltimore, Maryland on track 1 and New York, New York on track 2. If I press a button, I hooked up these little buttons here just for fun of it. Boom. I got Richmond, Virginia, Springfield, Massachusetts. And then I could go back. So that's just the way of showing you, a completely different project. But since I had this display here and we're going to do this, I figured I'd show you. So yeah, you can have your track billboard to show. Now you're kind of limited on space. So this is a 16:2 display. So it's 16 characters across and 2 down, but you can get a 20 by 4. You can get a 20 by 4 if you want a track billboard. So there's, like I said, there's nothing interactive or special. It just depends on what you want and however you want to, change your track display. Okay, very good. We are almost at 9 o'clock, and we are doing just fine. I have just a couple more minutes of stuff to show you. So we're going to turn that off, unplug my Arduino, zoom this out back to where we were roughly. Okay, so we have a DC power supply with a voltmeter, AC voltmeter, how that works. Can you change the font size? No, you can't really change the font size. It only has, a certain height in there, and you're kind of limited. I mean, you can get different kinds of displays. Let me see. No, I didn't look that up. No, you can't really change the font size. In other words, you only have a certain amount of pixels to make a character, a letter, or number. And then, there's 20 by 4 or the 16 by 2 is that all you get? And that's all you get. I was going to see if I could, you know what, Arduino. Yeah, I could do that. So here's a couple different Arduino displays here. So this is the 1602 that I was using. There's something completely different. Do we have the? Okay, here's the 20 by 4 right there. That's a touch screen there. So you can get actually LEDs for Arduino and go crazy and print whatever you want, but that's not what I was doing. So anyhow, what's up in the chat here? Nothing. Okay. Where was I on the StreamYard? Okay, let me go upstairs, show you what I got. This will probably take a couple more minutes. Okay. There's a lot more comments there. Wow. All right. Thank you all so much. So, yeah, here's Dave in the training room. Okay. Kind of hard for me to see what you're seeing there. Oh, come on. What's that? Okay. So here's the power supply that I made for my HO here. Let me find my screwdriver. I'll show you what's in here real quick. In there. Okay, so you could see what maybe you can, trying to need another hand. Okay, so in the back here, this is the laptop power supply, and what I did is I just sliced the case open on that, cut all the plastic off, and then here is the PWM voltage controller, like I was showing you. So this is separate, and then the rheostat or the variable resistor is attached to the roof. Come on, camera. Yeah. So that's mounted up there. So the actual thing is here. You can still hear me, right? Since I moved up here. I assume you can hear me because somebody else would be saying we can't hear you. So we're gonna do that. All right, let me put this together. At least put one or two screws in it. I mean, a couple of sparks around the training room. It happens, but try and keep it to a minimum. There we go. There we go. You'll see again, this one does have a current meter on it right there, but I did not hook that up on this meter. So I got a derailment. Uh-oh. Got a derailment here. Oh, man, oh, man. Now you did it. Obviously didn't have something on properly. Let me get these trains off the track. Where's my camera pointing? All right, so you can't see that display perfect, but anyhow, that's what we're doing here. Okay, so that's my DC controller, and then over here, sorry about that, guys. So there's my my ZW for my Lionel, and oh, let me plug that in. Okay, so you can see it. So I like how that works. That's a nice big display there that I could see from pretty far away. And again, I did this with the voltage regulator. Is kind of stuck to the back here with a little sticky tape. And this again is using a 9-volt battery to, we'll make sure you can hear me. It's using a 9-volt battery to power the display. And then, yeah, like I said, it's taking the power through a bridge rectifier and giving you a display. Sorry, I'm missing a lot of your comments here because that thing is up on the wall. Let me check out my comments here. Jeff N Scale Layout. You know, I did some videos on that stuff, and you know, if you need help, I've done some things with that. Just send me an email. Where did my train go? Okay, this is one of my favorite cars here. The Westinghouse has got a voltmeter right on there. I'm sure you can't see that. But anyhow, so that's my voltmeter train. I just saw a bunch of smoke come up, and I was a little bit concerned. I was like, "Uh-oh, I did smoke something." But this train actually has smoke. It's a smoke unit in there. So actually, the smoke unit was working. Let's see. I'll give you a quick look here if nobody's if you haven't seen my layout. So up on top is HO on the top like that. And then down here is my O gauge in case you've never seen my layout. Let me see. I'm sure you cannot see that there's a digital billboard over there above my hobby shop. And there we go. There's a camera. There's YouTube up there on the wall. That's being there's a Raspberry Pi that's connected to the internet there. So that's, I come up here and I can watch YouTube if I want. Thank you so much, Carly. Give you the whole thing real quick. And the incline project, if you've seen that. And then over here in a closet, kind of is the end scale that really needs some help. So, yeah. Okay, so that's what I have for up here. Let me go downstairs. Whoop. Oh, yeah, there's my train display there. Got to get a better camera up here. I had to get a camera that mounted to the tripod. I just have to get a better webcam. That's all. Okay, I'll be down. Okay, thank you so much. Oh man, smashing up my USB cables here. Well, that went almost perfectly. Well, pretty much. We got 35 at least watching. That's fantastic. A 2018. Yes, I have a couple of them. Yeah, those are great running trains. They're nice. They will tow a lot. They're heavy. That's one of the better ones. The 2026 is nice, but the 2018 will tow a little bit more. So yeah, the 2018 is pretty nice. Did I miss anybody in here? I noticed there were a lot of comments up there, and I was unable to watch them. Yes, I do. It's kind of sad. I'm thinking about putting that whole display on the other wall and kind of making an L shape or something. But if I move the display, I have to tear down the whole wall and run some new outlets. There are no outlets on that side of the wall. This is a house that was built in 1950, and I had to replace all the outlets on the other two walls, and I didn't tear up the inside wall on the other side of that room, and I should have, but I didn't, and I need outlets over there so I don't have power on the other side of that wall. So yeah, I wanted to make the layout just a little bit bigger, kind of make an L shape, but couldn't do it. Looking through my comments here, that's a lot of motive power. Thank you so much, Bob. Key lime pie. I'm not sure what that means. Did I hear someone say pie? Z. Yeah, I should put a Z scale like in the middle of the Lionel. That would be cool. It's happy smoke. Yeah. That's the kind of smoke that we need. Okay. So the only other thing, so this is a voltmeter that I bought on the Fleabay. It is listed as an AC voltmeter, and I paid about $6 for it from China. And when I power it up, like I did that LED display, it goes up to 10 volts, and that's it. No matter what the voltage going in, this will just display 10 volts. Plus the fact that I can't see this from across the room, so it's useless. So that's what you get for a $6 AC voltmeter from China. Junk. All right, let me see if there were any other comments. So yeah, if any of you have any questions about anything that I've ever done, send me an email. I mean, I like to work with other people on stuff and work on projects. Yeah, that's exciting. The ZW transformer. A little fun in itself right there. I am using an IR sensor on my trolley line. So, yeah, it hits the IR sensors and stops it and then reverses it. And trying to think if I did a test here. I did Arduino one time, and I had photo sensors in there. And then I guess you could use also, depending on how you're going to do it, you can do it with put a magnet on your car or something and then have a reed switch in the track. But yeah. Markland AC. Yeah. Ray, I have one G scale, and I showed that in my Christmas video. I have the Polar Express G scale, and I put it out front. I ran it around. The grandsons loved it, and I ran it for about an hour or something. They stood there and watched it for an hour, and then the dirt just got on the track. It got in the train. It was snowing. It was bitter cold. It blew off the track. So that was so I ran the G scale train for a couple minutes to do a video, and then another hour or so with the grandsons, and that's it. So I have one G scale. If they mounted behind the fascia with only the face, I did in fact make just like a cover plate, like you have on your wall plate, to fit these. And I don't know where they are, but I did in fact do that for something else. So in other words, if you want to just have a switch on your fascia and just drill a giant hole that the switch, drill like a 1-inch hole to fit your switch in, and then you put a trim plate over it. I did do that for something, and I don't know where it is. I could dig through the box, but basically you get the idea. It's just like your wall plate cover switch. Mr. Ray or Schuylkill River, John, if you could let us know who is next week. I'm sorry I don't have that information. Or Bob at PKW if you have the information for next week's live stream. Bob, PKW. Okay, fantastic. All right, very good. Okay, yeah, I knew we were going to go over an hour, so we're at like an hour and 13 minutes. I got through everything I wanted to do. I hope you had fun and learned something. I had a great time. Thank you all so much for joining. I think we hit a max around 35, maybe more. I don't know. But that was fantastic for me. Yeah, thank you. Great presentation. All right, Chuck Schreiber, thank you so much. Sorry, carry that punch show. Okay. All right. Very good. So I'll have to talk to Ray and see where we in there. March, April, May. All right. We'll have to see what we're doing. All right. Thanks again, folks. We'll see you next time. Peace.